Sequence, sometimes also known as progression, is an ordered list of numbers denoted by A1, A2, A3, A4 and continue on this way, corresponding to natural numbers 1, 2, 3, 4, 5 and so on, where A1, A2, A3 and so on are called terms of the sequence and which follow a definite order. Those terms are called terms of the sequence. So let's take a look on the sequence here and write next four terms. So example 1. Examine this sequence and we will be writing next four terms of the sequence. Write next four terms. Next four terms of the sequence. Here the given sequence is 1, 8, 15, 22 and 29. And what we are required, examine this sequence and write next four terms. If we examine this, let's name the first term as A1, second term as A2, third term as A3, this term as A4 and next term as A5. Now we will be writing A6, A7, A8 and A9. And if we take a look on these two numbers, the difference is 7. Again, the difference is 7, and every time we have a difference of 7 between consecutive terms of the sequence. So clearly, if we add 7 to 29, we will get the next term, which would be 36. So this term would be 36. And if we will add 7 to 36, what we will get is 43, and that would be the difference of 7 between 43 and 36. And again, if we add 7 more to this, we'll get 50, and by adding 7 again, we'll get 57. That would be the next term of the sequence. So required terms would be, required terms of sequence are A6, A7, A8 and A9. And A6 is 36, A7 is 43, A8 is 50, and A9 is 57. Let's do another question. And in example 2, again, we will be writing next four terms of the sequence. Write next four terms of the sequence. Now in previous sequence, there was a difference of 7 between successive terms of the sequence. But this time, that is not the case. Every time you look at the sequence, observe it and see what is the pattern. So this time, the sequence is given 7, 9, 12 and 16. So clearly, if we examine this sequence, the difference between the first terms is 2. Between second and the third term, this difference is 3. And the difference between third and the fourth term is 4. So there is a pattern of the differences 2, 3, 4, 5, 6, 7, 8. So obviously the next term will have a difference of 5. So let's write that down, 5, and add 5 to 16. We will have this as 21. And next time we are going to add the next difference, that would be 6, and the answer to this would be 27. And if we will add next difference, that would be 7, and the value of the next term would be 34. So that way we can continue writing the next term of the sequence. This time the difference would be 8, and the next term of the sequence would be 42. So this is how, and we have the required number of terms are 4. So 21, 27, 34, and 42 are the required terms. So let's write this down. This was A1, this was second, this was third term, this was fourth term, this was fifth term, and A6, A7, and A8. So A5, required terms. Required terms of sequence are A5, which is 21, A6, which is 27, and A7, which is 34, and A8, which is 42. A8, which is 42. So these are the 4 required terms of the sequence. In next question, what we are required is find the indicated terms. So this time we are going to write the 7th term of the sequence, and the given sequence is 1, 3 by 2. So let's write down the sequence. Example number 3. Example 3. Given sequence is 1, 3 by 2, 5 by 4, and 7 by 8. But this is the first term, this is the second term, third term, fourth term. And what we are required is that we want to continue to write up to 7th term, because in the question we are required to find out the 7th term. So here we'll write 5th term, A5, A6, and A7. Let's take a closer look on the terms of the sequence. In the numerator, there are odd numbers, 1, 3, 5, 7. So continuously, if we want to write down the 5th term, this is going to have 9 in the numerator. The next term is going to have 11 in the numerator. The next term is going to have 13 in the numerator, because this is in the numerator, this is the sequence of all odd numbers, 1, 3, 5, 7, 9, 11, 13. In the denominator, if you take a look, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 would be 16, and 16 times 2 would be 32, and 32 times 2 would be 64. So this is a pattern in which we can write down the terms of this sequence. So required term would be required term, which was A7, is equal to 13 over 64. Now we will do the next question, and this is, let's write it as an example 4, and this time we are going to write the 11th term, and the sequence given is 1, minus 3, 5, minus 7, 9, minus 11. So let's write this down. Example 4. Given sequence is 1, minus 3, 5, minus 7, 9, minus 11. If this is the sequence, let's write down 1 as A1, this is A2, this is A3, A4, A5, and A6. So this is how we can write. The first term is 1, second term is minus 3. Obviously, if we continue like this, we would be required to write down 11th term. That would be A11. So here would be A7, A8, A9, A10, and then A11. If we carefully examine the terms of sequence, these are all odd numbers, 1, 3, 5, 7, 9, 11, but alternatively they are changing sign. So next number would be 13, and the next would be minus 15, next number would be 17, and next number would be minus 19, and the next number would be 21 with positive sign. So this is just matter of observing or investigating the terms of the sequence, what pattern they are following, and then according to that rule you can write any number of terms required. So here A11th required term is A11, and this is equal to 21. Let's find out some terms from the general rule, or when the nth term is given. Now here in example number 5, given nth term is denoted by an, and this is given equal to minus 1 power n time n square. Now when nth term is given, it's very simple to find out the first, second, third, fourth term. So when an is given, let's write down the values for n. When n is equal to 1, what would be? We simply are going to substitute the value of n, and this would be a1 equal to minus 1 power 1 into 1 square, and this would be minus 1 power odd is always going to be negative in the answer. So minus 1 time 1 square is 1, so this is 1. And a2, now we are going to substitute the value of n as 2, and a2 is equal to minus 1 power 2 time 2 square. So this is minus power even, and whenever a negative has even power, this does have positive sign. So this is plus, but 2 power 2 is 4. Let's write it as such. And when n is equal to 3. Then how is A3 equal to? A3 is equal to minus 1 power 3, and this would be 3 power 2. And negative power odd, answer is negative. And if we want to write it 3 power 2, we can either write it this way, or if we want to fully expand this, we can write it as 4, and we can write this as 9. And for the next term, so n is equal to 4. This time A4 is going to be equal to minus 1 power 4 into 4 square. So this would be equal to, because here minus 1 has power even, so this will be positive. So this would be plus 16. So required number of terms, we were required to write only first 4 terms. So the first 4 terms of sequence are, what are the first 4 terms? Minus 1, 4, and minus 9 here, minus 9, and minus 1, 4, minus 9, and 16. And we can continue this way. And if we want to do another question, example number 6, this time we have nth term given an minus 1 is equal to n plus 2 is equal to n plus 2, where it is given that the first term of the sequence a1 is equal to 2. First term is already given, so we should start with value of n equal to 2. When n is equal to 2, we could only start with natural numbers. So 1 is already given, that's why we are starting with n is equal to 2. Here, if n is equal to 2, then a2 minus 1 is equal to 2 plus 2. This means a2 is equal to a1, because a2 minus 1 means 1. a1 plus 4 here, this is a1 plus 4. Since a1 is equal to, already given that this is 2, so if we substitute the value here, this would be 2 plus 4, and the answer would be equal to 6. Similarly, we can substitute now n is equal to 3. When n is equal to 3, this time this would be a3 minus a3 minus 1 is equal to n plus 2, means 3 plus 2. If you look in the general rule, that's given, that's n plus 2. This means this would be 3 plus 2. And now we can move this a3 minus 1 on the other side, and this will give us a3 equal to a2 plus 3 plus 2. And since the value of a2 is already calculated equal to 6, therefore this will be equal to 6 plus 3 plus 2, and the answer for a3 is equal to 11. And now when n is equal to 4, when n is equal to 4, then this would be a4 minus a, 4 minus 1 equal to 4 plus 2. Again, the same way, we are going to transfer a4 minus 1 on the other side, and this will give us a4 equal to a3 plus 4 plus 2, which is already here. Since we have just recently calculated the value of a3 equal to 11, a3 is equal to 11, therefore this would be 11 plus 4 plus 2, and this would be 15 plus 2 would be 17. So this would be equal to 17. That's how we can find out the first few terms of the sequence when the general terms are given. So the first four terms of sequence are what are those terms? The first term was given, that was 2. So this is 2, 6, 11 and 17. 2, 6, 11 and 17. 2, 6, 11 and 17. We can similarly find other terms of the sequence just by substituting the values of